Welcome to Spring LIB.
So in this question, a spring obeys force law by the expression F is equals to minus kx plus ax cubed plus bx4 I, which means that this force function, which is dependent on x, is a function of x, as you can see, and this I stands for the unit vector along the x-axis. And the question is whether this force is a conservative force or not. Well, according to the definition of conservative force, if the work done by the force on an object moving from some initial position x1 to some final position x2 depends only on the endpoints. So this force, which is here, is conservative if we can prove that the work done by this force as the object moves from some position x1 to x2 depends only on x1 and x2 only, and only on the endpoints, the force is going to be conservative force. So we're going to write an equation for the work done by calculus is equals to the limits x1 to x2. I'll write the vector form first, f dl, and then I'll write f dx because the force is acting in the x direction, and I'll just plug in the values here. So we'll get x1 to x2 minus kx plus ax cubed plus bx4 dx. Solving the integral, we'll get minus half kx squared plus 1/4 ax4 plus 1/5 bx5, and apply the limits of x1 to x2 to this and plug in the answer, and you will get minus half k x2 squared plus 1/4 a x24 plus 1/5 b x25 minus half k x1 squared plus 1/4 a x14 plus 1/5 1/5 bx15. So as you can see that the expression for the work done by this force depends only on x1 and x2, and rest all of them are constant, therefore this force is a conservative force. All right, for the second part of the problem, it says you have to derive the potential energy function. Well, potential energy as related to the force is given by ux is minus integral f dx plus c. So this is simple. So we just plug in the value of the force function, which is equals to minus integral minus kx plus ax cubed plus bx4 dx, sum plus c. So if you solve that, you will get minus kx squared by 2 plus a x4 by 4 plus b x5 by 5 plus c. And multiplying by this negative sign, you get kx squared by 2 minus ax4 by 4 minus 1/5 bx5 plus c. And this is our potential energy function.